If you want to be as unfazed as that guy was about roller coasters for your 5 mark GCSE energy transfer questions, then watch this video. So this is a little bit of a hack for you. If you get a question that asks you to work out the maximum speed of something like a ride when you're given the height. And these are usually free fall questions, and it's actually easier than you'd think to get 5 marks on these questions. So I thought I would use the ride stealth to show that this concept works, right? So the whole idea of this is, with stealth, it's a nice and easy example because you essentially get fired to the top of the ride and then you just come back to the bottom. And we want to know what the maximum speed of stealth is. And we're going to model this as a 5-mark energy transfers question. What is the maximum speed of stealth? Now, as sad as I am for knowing this, the height of stealth is 63 meters. So the ride itself is 63 meters high. And you actually, if you want to work out the maximum speed of the ride, you actually only need to know the height. But there is a little bit of a caveat to this, and that's the fact that in order to use the height to work out the maximum speed, all of the energy that you have as gravitational potential energy at the top needs to be converted into kinetic energy at the bottom. And I'll show you why that makes such a big difference. And in the question, you will often see something like calculate the maximum speed. I'm going to write it as Vmax, but it will say maximum speed. And as soon as you see maximum speed, you know that you can use this equation. So what does the equation look like? Well, it relies on all of the gravitational potential energy at the top of the ride essentially becoming kinetic energy at the bottom of the ride. What I mean by that is if you had, for say, 100 joules of gravitational potential energy at the top, it would have converted into 100 joules of kinetic energy by the time you got to the bottom. And the reason why this is useful for us is because, well, the equation for gravitational potential energy is m times g times h, the mass of the object multiplied by the gravitational field strength times the height. And the kinetic energy is a half times the mass times the speed squared. Okay. So why is this useful? Well, one thing that we can mention before we even start is you can see that there's an m on either side of the equation. That's the mass of the object, and we can see that obviously in the ride it's, you know, the mass of the people and the cart that's falling down. That's actually independent of the mass. This equation doesn't depend on the mass. And like I said, the reason for that is there's no energy transfer. And we're not talking about terminal velocity. It's just a ride that's falling from a height and it's reaching its maximum speed. So we have GH equals to a half V squared. We times the 2 to the other side. So 2GH equals to V squared. And then we get an equation. I'm going to call this max here, maximum speed. We'll get an equation whereby we square root the other side and we get that the maximum speed should be equal to the square root of 2 times the gravitational field strength times the height. Okay, interesting. Let's see if it works. So G is given to you on the data sheet, and it can be rounded to 1 or 2 or 3 significant figures. I'm just going to use it as 9.8, so 2 significant figures. But like I said, this would be given to you on the data sheet. The height, we already know, is 63 meters. And so now if we substitute into our equation, Vmax equals to the square root of 2 times 9.8 times 63. We get, well, let's do the calculation. So the square root, we need to clear that. The square root of 2 times 9.8 times 63 gives us 35. Now, what you've got to remember about that number, that's in meters per second. So if it looks unfamiliar or it looks very slow, that's just because it's in meters per second and not kilometers per hour. Now, since there are 3,600 seconds in an hour and 1,000 meters in a kilometer, if we want to convert this into kilometers per hour so it's more familiar, we can divide by 1,000 and times by 3,600. So divide by 1,000 times by 3,600, and that essentially gives us a multiplication factor of 3.6. So to get it into kilometers per hour, we just need to multiply our answer by 3.6. Let's have a look. Equals to 126 kilometers per hour. Okay, cool. And if we round that to two significant figures, we get 130 kilometers per hour. So that is my estimation of the maximum speed of stealth based on energy transfers. We're going to check the answer in a minute and see how close it is, because we can Google how fast stealth is. But my point with this video is this equation, if you're confident with maths, since you get given all the equations, if you can remember this one and you get a question on energy transfers and it says calculate the maximum speed, this is often a 5-mark question. So you're getting 5 marks for doing very little work. If it's 5 marks, if you can get your head around that. So before we finish, let's have a look and see what the actual speed of stealth is, and we'll compare it to our value. So maximum speed of stealth. 129 kilometers per hour. So we were very close. In fact, to two significant figures, it's the same. So happy days. And see you next time.